Hit the record button this time. All right. So 10.1 is the Cartesian coordinate system. Ten one and 10.2 today. And then Wednesday, I'll do 10.3 through 10.6, and we'll have chapter 10 done. And then y'all's first, all this homework, due Sunday. Practice test, I think, has already opened up today if you wanted to get ahead of it to study, because your first test is next Monday. Yeah. All right, so here's a few notes before we get into it. This is a Cartesian coordinate system plane. This number line you are familiar with. This is my x-axis. This is what we've been graphing on as a one-dimensional shape. But now we're going to add in a y-axis. This now makes it two-dimensional. So we're taking our normal number line. Five dashes if you're trying to count. And this is my y-axis. Now, just like in a number line, the intersection 0. So this would be 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. So left is negative, positive is, or right is positive, just like a normal number line. The addition to this on the y-axis is if you go up, you're going to go to +1, 2, 3, 4, 5. And if you go down, you're going to have -1, -2, -3, -4, -5. This is called quadrant 1. They use Roman numerals. This is quadrant 2. This is quadrant 3. And this is quadrant 4. So if it ever told you to look in a certain quadrant, it goes, it's like it makes a C basically for Cartesian. Right? Like a C like that. What that means is in the first quadrant, your coordinates are all positive. Your x-axis is positive and your y values are positive. So two, like positive, comma, positive. Your x value is positive and your y is positive. In quadrant 2, you can see that your x values are now negative and the y-axis is still positive. So now our coordinates will be a negative number, comma, a positive number. Because instead of giving you one number to graph, I'm giving you two numbers to find out where it is in this two-dimensional plane that we have. If you're in quadrant 3, it's because your x-axis is negative and your y-axis is also negative. And the last one, if you're in quadrant 4, your x-axis is positive and your y-axis is negative. Just so you're aware, the way we graph is we start with the x value. So we'll go left or right first, and then we graph the y value, which is second. So then from that value, we'll go up or down. So with that said, let's do a different color. Let's, on number 1 here, let's graph point A, and we'll call it -3, 2. So what this means is I'm going to go -3 on the x-axis first. So I'm going to go to -3 on my x-axis, which is located right here. I'm not going to put a point there. This is where I'm going to start. So I'm going to go on my x-axis to -3. And then my y value was 2. So then I'm going to go up to 2. So that right there would be my A. So I went over 3, up 2. Are we okay with that? Oh. I don't know if that made it better. Oh no, I can make this better. Hey. Or you could be like me and start with bad vision and then just getting worse every year. Yeah, I don't know how I feel with the laser thing. Hey. Hmm. All right, so let's graph negative 1, 4. So now that you kind of have this idea, I'm going to start at the origin. What direction will I go first? Okay, I'm going to go left 1, then what? Down 4. Perfect. There's your second point. Is that making sense? Okay. Let's look at another point. Let's do 3 comma negative 1. Sorry, at the origin, which direction will I go first? To the right, then down. Perfect. That's roughly right there on top of that 3. But there's your C. We good? Okay. That's it. 3 comma 3. Where do I start? All right, so what is it? To the right. And then up. Perfect. All right, last one, and I'll feel pretty confident. 4 comma 0. Where will I go first? Then what? That's it. If you get 0, that means you go nowhere, and I'll stop there. Very good. All right, well, that's the first set of your questions. So let's do some more. Actually, this is what I'll do. I'm going to write them over here. Give you an opportunity to try it. It'll give me time to graph as well. So graph, and if you want, you can put on the same one if you want. But I want you to graph -3, -1, -2 comma 0, 0 comma 2, 3 comma 1, 4 comma -3. I'll give you a second to graph those. This is horrible. I had a professor once. I think it was my last semester. It's an abstract calculus vertex or whatever it was. I don't even remember the course because it's so bad. But he wrote this and he goes, "What defines a straight line?" And I was like, "The shortest distance from point A to point B." Then he goes, "Define the shortest distance." I was like, "Are you kidding me?" Like it was horrible. On your homework, you'll have a nice coordinate plane. And all you gotta do is just put the plot and label it right. We good? All right, let's check. So through -3, -1, I would do what? Perfect. B, perfect, and stay there. C, up. 0, I won't go left or right, and then I go up to. Very good. There's my C. D, very good. And then my E. Oop, should I draw a line? Roughly there. Perfect. Yeah, so if you get 0, comma number, that means you do not go left, right, and then you either go up or down, depending on that number. Good there? All right, the next part of your homework. So we'll say this is question 3. They're going to give you an equation. They'll say x plus 5y equals 15. And then they're going to give you values. They're going to say 0, comma, a number, comma, 2, 15, comma, a number, and then 30, comma, a number. And what they want you to do is to plug it into the correct value and then solve for the unknown. So for example, this 0 is for which letter? X. First numbers are your X, second number is your Y. So that means I'm going to take this 0 and I'm going to plug it in right here. So that gives me 0 plus 5y equals 15. Now, do I necessarily need that 0? No, so I can go ahead and drop it. So if I have 5y equals 15, what do I do to solve? I do that all the time. So there's the first part. So now we do the same thing to this one. This 2 would go to the y. So this becomes x plus 5 times 2 equals 15. One thing I do want you to notice I put this 2 here in parentheses for my y. I do that to indicate multiplication. A lot of students, they'll replace the y with a 2, but then it'll look like 52. So then they'll subtract 52 instead of multiplying first. So do watch out for that. Dot's fine with me as well. I just know what I've seen some students do. So now that I've replaced my y with this 2, how do I solve? What do I do first? Which is 10. Very good. So this is now 5, comma 2. Go ahead. Okay. Yes, ma'am. This is adding. Mm-hmm. Yeah, it's basically we're going back to chapter 9. So we're plugging in a number and then solving. All right, so I'm going to do this next one here. This is 15. It goes to where? My x. I'm going to write it over here. So I get 15 plus 5y equals 15. Very good. Then what would you do? So now it's 15, comma 0. Still okay? The 30 belongs where? Where the x goes. This is going to be 30 plus 5y equals 15. So what would you do next? Minus the 30. Very good. There you go. So that's what it's going to do. It's going to give you an equation and ask you to finish what the coordinates are. All right. Another way they can ask the same question. No, it just says just answer the missing values of the coordinates. Yeah. So the other way they can do it is they'll ask you to complete a table. So they'll say, all right, your equation's now y equals negative 3x plus 2, and they want you to fill out a table. And you get 0, 1, -2, and 0. And then they come over here and they go, once you get the missing values, now we want you to rewrite it as a coordinate. All right, so same work, to just present it to you differently. So if I start with the first one here, this 0 belongs to what value? So I'm going to plug that in. So I get y equals -3. Okay, when I replace something, I like to use parentheses to indicate multiplication. You can use the times button as long as you know you are multiplying. So what do I do to figure this out? Do your multiplication first. So -3 times 0, 0. And so 0 plus 2. Ooh, still combining like terms here. So it'd just be 2. So your y is equal to 2. Not much solving there. That's more of a evaluating. So I put a 2 here. So then my coordinate would then be 0, comma 2. All right. Yeah, I'm making a table. They don't even ask me to graph it. They're basically just, I'm coming up with points for a table. This is gearing us up to do the next lesson, which is graphing it. Right. So what's this 1 belong to? The y. So this becomes now 1 equals -3x plus 2. So now I do have a little solving to do here. How do I solve this? Good. Two negatives to make a what there? So that'd be positive 1/3. So you can leave it as a fraction, turn it into a decimal, but that would be what this is. So then my coordinate then is 1/3, comma 1. And that's a 3, by the way. Good there. So again, remember on this step right here, the 2 negatives right there, that's what makes that a positive. Gotcha. Where does this -2 now belong? The x. So now I get y equals -3 times -2 plus 2. So what will I do first? Very good. Perfect. Times negative. Two negatives would make it a positive, and then 3 times 2 is 6. Mm-hmm. And then now we have our coordinate of -2, 8. And then last one there, that 0 belongs to. So now I get 0 equals -3x plus 2. So what do I do to solve? Subtract my 2. So you have $0, you borrow 2, now you're at -2, and then divide by the -3. Good. The 2 negatives there make a positive 2/3. So I then get 2/3, 0. Good. All right. The next stage, I'll ask you questions like this. It'll say, given y equals 4x. Oh, this is number 5. Given 4x minus 3, determine if any of these ordered pairs is true, basically. So 0, -3, 3, 6, 1/4, -2. To determine if something's true or not, you're going to take each value, plug them both in, and see if it gives you a true statement. So remember, these are your x's and your y's. So I'm going to replace the corresponding x and y's. So if I do that to this equation, what will I get? I'm going to replace this x and this y with this x and this y. Well, if you're replacing the x goes away. So there it is. So I replace that y with -3, replace that x with a 0. So instead of only replacing one of them, we're replacing both of them. And now we're just going to evaluate to see, is this a true statement or not? So for starters, what is 4 times 0? 0. And 0 minus 3? So does -3 equal -3? Yes. That means that coordinate is yes, that is a solution. How would I plug it in using the next points? Perfect. And so then we work it out. So what do I do first? 4 times 3 is 12. 12 minus 3, 9. So does you're good. So does 6 equal 9? No. Yeah, fractions. That's a misconception too, especially how it's written. We want to put the X here since that's the first unknown letter, but it's the X goes there and the Y goes there. So do watch out for that. Yeah, a lot of students do want to do that. So before we see that there is a fraction, yes, it's going to be the harder because it's a fraction, but how do I plug it in correctly? Okay. And then what would you do first? So what is 4 times 1/4? That's if we're solving. Here we're just evaluating. It'd be a whole. Yeah, because technically, yes, if you want to multiply this straight up, 4 times 1 would be 4, 1 times 4 would be 4, and then 4 divided by 4 is a whole. What this is basically stating, how many quarters, or if you quartered up 4 holes, I guess. If you had 4 pies and you had to split that up into 4 groups, you would have 1 pie in each group, is basically what that's stating. So it'll be 1 minus 3, which is? So it does -2 equal -2. Yes. So we're good there. Okay. Yeah, that one there, you just plug in it and you're just determining is it a true statement or not. Yeah. But no, if you did multiply this straight across, 4 times 4 is 4, 1 times 4 is 4, and then 4 divided by 4 would give you the 1. So if you wanted to go through the whole process, that's exactly what's happening too. Go ahead. With the other class, I don't know any. Oh, you don't have to send me nothing. Yeah. The test, you'll turn in your work on the face-to-face. The one test number 2, that's going to be a online open book test. That's the one where I'll have a drop box where you turn in your work. Yeah. The rest of them, you'll turn the work right into me because you're here. It'll all, yeah, we'll take it on the computer. Mm-hmm. That's it. Yeah. Yeah, that one I don't know much about. All right, last question on 10.1, and then we'll move on to 10.2. What they're going to do now is they're going to give you a graph, and then they're going to ask you to pull some points from it. So I'm going to do my best attempt to give you a good graph so you can get some good numbers. I wish there was like a grid or something. I think I've looked once before. Yeah, I don't think so. This is a whiteboard. Oh no, my whiteboard. Okay. Host tools. All right. Well, it's okay. All right. So here we go. So you're gonna have questions that look like this. Oh, this is gonna be hard. Okay. Let's pretend this looks pretty. Yes, ma'am. Yeah, 3, 5. But that's what the question's asking. Taking this graph, can you give me 3 points on this line? Go away. Yeah. Mm-hmm. So the way you would do that is, I wish I had a something better on a grid paper. I don't. Yeah, and you'll have a nice graph. What's more? What's this give me options for? No, not what I need. Yeah, that's what I was looking for. All right. Okay, so the basis of it, so I'll just probably just do this one, but you'll get a nice, pretty graph. And your goal is to just kind of look on here and look for any good points. When I say good points, you have grids that look like this, right? Good points are ones that intersect at that crosshair right there. So you don't want to get this point because it's like slightly above it. So that wouldn't be a good point. But better graph. That point right there, that would be a good point because it's on the crosshair of these boxes or the grids that are in your coordinate plane. So it'd be this one here. Mm-hmm. So yeah, so that right there would be 3, 5. And that's what it wants you to do. So look at a graph and pull some points out of it. It's a bad drawing, and I don't know how to make this better, but that's what you're looking for. Yeah, they'll have all the grids and and you just literally go which one's going to be on the cross because it's going to have some like this as well. Where it looks good there, but it's slightly above it. So that wouldn't be a good point. So you want something that goes right through a crosshair. That makes sense? All right. And that will be pretty much the conclusion of that homework. Yeah, so yeah. So yeah, if it were to go into it even right there, the 0, 3 would be a good option as well. So 0, 3. Mhm. This one here. See, this one, my graph's not so good because it's a little off. But if it was to go through it, yeah, it'd be -4, 0. Mhm. Yeah. X first, then Y. So you start at the origin and then you go to the X and then up to the Y, wherever that coordinate's at. Yeah, no. Uh, oh no, but yeah, that one there's no math. You just gotta look at it and then pull the correct point the correct way. Because that would be the thing. Is some students might pull Y comma X versus X comma Y. Yep. All right. So then to wrap up tonight, we're gonna talk about 10.2. Which is now graphing two variable equations. So this green line that I attempted to graph, you'll now be able to graph in 10.2.